Hello everyone, Assalamu alaikum. So welcome to the electrical workshop in workshop building. This is the lab workshop it is, where I am recording the lab lecture of electrical workshop. In this workshop we have three parts, that is electrical wiring and PCB, printed circuit board, and we have measurements and devices. Now we will start with electrical wiring lab, that is electrical wiring lab part here. So directly jump to the experiments in it. So in this we have some experiments: wire joints, soldering and preparation of cable using workstation, color code for network cable crimping, two-way wiring and types of electrical switches, staircase and go-down wiring, AC voltage regulator, and last one is electrical wiring inside the computer, that is called system assembly, that is personal computer assembly. So these many experiments we are going to study in electrical wiring lab. So just we will start with the first experiments, that is wire joints, soldering and preparation of cable. So experiment number 1, joints. So we have three parts in this again. First we will study about the joints. Before the joints we will study about the conductor, insulator and semiconductor. Next we will study about the soldering, how to make a soldering in electrical and electronic way. Next, preparation of cable using workstation, means how to prepare a cable using a workstation. That box I will show it while in the practical session. Now first, before going to the wire joints, what is a conductor? We have different material in nature. So based on that one definition, we can define a conductor. So a conductor is a material through which electricity will pass freely. So I will repeat, a conductor is a material through which an electricity will pass freely, means electrons will pass freely from one point to other point with a voltage difference. When there is a voltage difference or potential difference, electrons will pass from one point to another point freely, no stoppage. It is called conductor. So conductor, what are the materials of conductors? If you take the materials, good conductor we can say copper, aluminium, steel, iron, gold, silver, platinum. So these are the conductors. But if you best ranks, if we have platinum, which is very costly, and gold also very costly, and silver also very costly. But based upon the strength and resistivity, good conductor we can say copper. After the silver, next category it will come to the copper, which is generally used in the household wiring. And next category it is coming to the aluminium, which is all used outside the buildings. Let's get outdoor purposes we can say, means outside the building, like ACSR conductor, aluminium's conductor, steel reinforced, those are used for the transmission. In that all our aluminium conductor is there and steel conductor also is there. So like this we use aluminium. Now next category will come to steel, which is having high tensile strength but not that much good as copper and aluminium. Next another category is iron. So these are the different conductors. Now coming to the insulator, the opposite to the conductor is insulator. So insulator definition I can say, it is a material through which an electricity or electrons will not pass at any cost. So the electrons will not pass, it will stop. So what are the insulating material or insulators? We can say wood, glass, plastic, we can say these are the different insulators. PVC, polyvinyl chloride, that's also an insulator. One thing I want to add here, the wood when it is in dry state, means there is no water inside the wood, it is not dipped in the water and it is not with a moisture, then it is a good insulator. If it has a moisture inside a wood or it is a wet in nature, then it can act as a conductor also. So be careful, the wood is a conductor and insulator based upon its moisture or water content inside it. So another example, insulator we can say diamond, like a glass, diamond also an insulator. So these are the insulators and the conductors. Now coming to the in between semiconductors, through which the electrons will not pass freely or will pass freely also, means it is in between the conductor and insulator. These materials are silicon, germanium and different doping. If we add, those also will come into the semiconductor. We are not going to in depth of the semiconductor, just we have to know the definitions of these three: conductor, insulator and a semiconductor. Now coming to the wire. Wire is nothing but it is a combination of a conductor and an insulator on it. So it is called a wire. Combination means I can show it. This is the wire where copper inside a insulation, a copper is there. So this is a wire. Inside a insulation or an insulator, this is a PVC, polyvinyl chloride insulator. Outside it is there. Inside there is a conductor, copper conductor. You may have aluminum or different material inside, but the combination of these two, a conductor and an insulator on it, it is called a wire. Okay. Now what is joint? Joint is nothing but it is the junction of two different wires is joint. Means if I want to join two wires, I know what is a wire. Wire is nothing but a conductor and an insulation on it. So inside the insulation of that wire there is a conductor. So joining these two conductors of two different wires is called a joint. So we have different methods of joints like Western Union splice joint, pigtail or rat tail joint, married joint, many are there. These three are very important in our lecture. This we will study about the wire joints. Now coming to the joints. Here I will take a cutting clear. So I am having one wire here and another wire. Two wires I have in my hand. So what is a joint? Joint is nothing but junction of two different wires on conductor nature. That is, we are joining the conductor of the wire. Means we are not joining the insulator, we are joining the conductor of the two different wires. So first, if we go for the rat tail or pigtail joint, I will make it up. Okay. No, I need a Now I take a crimping tool through which I can remove the insulation of the wire. So just I will cut once again here. There is a cutting plier. So what I am doing? Just I am removing the insulation of a wire. Means I am removing some part, maybe 1 or 2 inch. Generally I use 2 inch. Just use the upper blade and rotate twice or thrice and remove it. Now here also I am removing the insulation part of the wire. You be careful, wire should not cut. Now here if you see this wire, we have multi-strands of copper. Generally we have two types in this. One is single strand and multi-strand. In maybe 10 to 15 years back we used to have wires with single strand, and the disadvantage of this single strand is for long run, due to the heat conditions or weather conditions, the conductor will damage or it may break inside the insulation somewhere. So the continuity or connectivity will lost. So to avoid that, we have multi-strand conductor through which if one of the conductor or one of the strand of the conductor is broke inside or conductivity is gone, the other strands are there to take care of the continuity of the conductor, means electricity you can say. So the first we will go for the pigtail and rat tail joint, both are same names for the same. What we are doing here, just I removed insulation of 2 wires, maybe around 1 to 2 inch. I removed. Now what we have to do? Second step, we have to join like this. We have to join like this and rotate. Just rotate. I'll rotate like this. And you can use cutting plier. This is called cutting plier to make it smooth at the edge, at the ends. Now, if you want to make bend here, you can bend so that sharpness of the conductor ends will not affect your hand. So, see, this is pigtail or rat tail joint. Same like this, pigtail and rat tail joint. It is the simplest joint in the electrical wiring, and but not it is an rugged one, it is not used in the concealed wiring or in inside any tubes, because the problem is when you use the pigtail or rat tail joints, what happens, it look like it 2 different conductors and some bulge is outside the conductor. When I put this wire inside a conduit or in a pipe, it will disturb the other wires with this extra tail, we can say, in nature. So this is not used in the concealed or conduit wiring. So it is used only in open or in the boxes where junctions, visible junctions are there. Okay, so that's why we are telling simplest but not the best one. So next we have another 2, Western Union splice joint and married joint. Now this married joint and Western Union splice joint, the technique, the procedure is same, only the difference is here Western Union splice joint having single strand conductor, not multi-strand, but here married joint multi-strand is there. Remaining all the procedure and technique is same. So we will go for the practical. See here, I will cut this one. Okay, same procedure, up to 2 inches, remove the insulation by using insulation remover or crimping tool, up to you, whatever in your tools permit, you use it. Now this also 2 inches almost, just rotate 1 or twice and remove it. So don't worry, 1 or 2 conductors may cut because it is a multi-strand conductor. 1 or 2 strands, if it is detached or cut, no problem. Now we have 2 wires in nature. It's a big wires will be there. I am using for demonstration a small part of the wire. So these are the 2 wires which having 2 inches insulation removed, and it look like this. Because I told you Western Union and splice joint, marriage joint, both procedures are same of making. Now what is the next step? After removing the 2 inches insulation from the wire, what is the next step? In this 2 inches or whatever the size, maybe 2 inches or 3 inches or 1 inches, half of the conductor, strands of the conductor, means from the bottom, you have to make it tight. See, you have to make it tight. Half of it. Remaining half strand should be freely open and apart, distant apart, so that you can look like this. Same thing for this, rotate half of it and make freely open. So this is how it look like. Now when I use these 2 halves, make to the center. up to the center, make like this. Again I am telling, this is like this. One of the conductor should be 90 degrees rotated and mix it up to here and hold one side till the half. Now remaining conductors you just grab it and make like this, or join together, and from the down side rotate this, rotate like this, clockwise or anti-clockwise, spiral, rotate in the spiral way. Then use the cutting plier to fix it. Now again use this side also, take the conductors and rotate in this manner, in the spiral manner, and use the cutting plier to make it fixed. So see, this is your married joint, married joint, or Western Union splice joint if we have a single strand conductor. This is multi-strand, that's why this is called as married joint. Now after finishing this married joint, we can put a tape, electrical insulation tape, we can say electrical insulation tape we can use, so that the conductor part will be covered with a insulation, electrical insulation. Use it like this, make it tight, no moisture should go inside, make it tight. This is about the first part, wire joints. Next we will go for the soldering. See, like this we have to keep it. Okay, this is married joint. Now about the soldering, I will just remove this tape once again, and I will show what is electrical soldering. What is electrical soldering? Now here, to make more strong this wire, this connection joint, I can say, to make more strong, I will solder this area, the open area, with a soldering material, LED soldering material, and with soldering paste, so that these two are different material. This is copper, that soldering material is LED, so these are not mixing together because of the having different melting temperature. So to make it mix, we are using soldering paste so that it can attach on the copper. Okay. Now coming to the practical second part, that is soldering. Soldering, we are using either a simple soldering lead, soldering iron, or we have multi-purpose workstation where we have soldering station and we have assembly rework station. So two things we can do in this. One is by using this soldering iron, we can use soldering, and we can use this hot air blower for making cable. So we'll come to that part later, cable. Now first to the soldering. Now in this soldering, what the material or items we need is soldering lead. This is the soldering lead, what we call, where this is the fine solder we are using. The material is lead. Okay. Now because that is a lead, one material, this is a copper, we need a something flux, that is called soldering paste. So this is the soldering paste, where I can show it. So this is the soldering paste. By using this, we can mix both material. So before starting the soldering, what we are doing? We are using this soldering rod to make heat up. How to do that? We have two switches here. First, hot air and soldering. So I switch on the soldering, and this is the portion where the soldering iron is connected, and this is the temperature control of the soldering iron. Now I am using 400 and above, or mostly 450 degrees centigrade to get heated up, this soldering iron. Now meanwhile it is heated up, maybe 1 minute it will take. Before in that time, what we are doing, this married joint, what I am doing, I will add this paste, soldering paste evenly, thoroughly on the surface or junction of these wires. I can say now it is only wire because two already joined. Okay, now next, just open this slightly, so lead, so that what we are doing, we have to melt this lead step by step and we have to pour on it. So how to do, just take it, it is heat out now, yeah, the fumes are coming, see, hot fumes. Now if you see here, see, it is melting. So just you put beneath of this material lead and melt slowly and keep on it. First you unevenly put some dots here, so the lead material, the molten lead you can say, and put some part here, some here and there, here and there. This is surely different than the electronic soldering. This is electrical soldering, I can say. Electronic, we have electronic components like resistors, transistors, diodes, capacitors. Those we'll study in PCB, printed circuit board lab. Here only to make this joint strong, I am using this one. Okay. Now you can see this is it is not evenly spread on the junction. So what I have to do, I have to use this again soldering rod and make it smoothly spread on the junction or on the conductor. Just make it smooth so that is evenly spread on the junction. Okay. Now you will keep it here, you will switch off this one or make it temperature down to 0. Now you can see here all the solder, that is lead, lead is spread on the complete junction evenly. It doesn't have any dots or everything. Okay. So what is the next step is use insulation, electrical insulation tape to cover on it. Okay. So make it tight. Now it become like a single conductor, not two conductors, two wires, not a two wires, it is now it is a single wire. So see. Now what is the next is, it is cable shelling. So soldering is finished, now we will go for the cable shelling. So this is a cable shelling by using which we can make a cable. So how it look like, see, this is a cable shelling, a hollow inside. Based upon the thickness or diameter of this hollow nature, we are using the sizes, different sizes of the wires. Now if I want to add, I need some other wire. Okay. Now I am using another wire. Now what is a cable? First definition we will study. Cable is a combination of two or more. Combination of two or more strands of wires. Two or more means two or many strands of wire together with a new insulation. Maybe a cable shelling or maybe another insulation which is placed in industry. So that is called a cable. Cable is a combination of two or more strands of wires with a new insulation on it. So what we are doing, we are using a cable shelling, and we just putting these two wires inside the cable shelling, and just pass on it. So now it is how it is. It is very free. It is not finished. It is not fixed. So for that, what we need, we have to fix this freely moving cable shelling to a fixed position, and it should be strong so that it should not come out. So for that, what we need, a hot air we need. Okay, before that I will just do this. Yeah, hot air. For that hot air, we have two controls here, air and heater. So in this, a air blower is there inside, through which air will come out from this, and a heater is placed inside, so that you can see that heater, red in nature. Inside there is a heater. If you increase the air, it having number from 1 to 8, you can use 7 number, and heater you can use minimum maximum, there is no number, so you can use minimum near about maximum. So you can see inside red hot, you can see here, yeah, that's not red hot, that is heater inside. So what it is doing, that hot air will slightly melt and fix this cable shelling on the wire. So just you can start from left to right, or right to left, or from center to left and center to right, and slowly you have to rotate step by step. Okay, because it is a small cable, we are using hot air, but for very thick cables or thick wires like power industries, transmission, distribution, there we use what you call, we are not using hot air, there we will use fire. We use fire, some gas fire we will use. With this, that cable shelling will melt easily. Here the cable shelling thickness is very small, so that's why hot air is enough. But there the cable shelling thickness is very huge, so to melt that one we need a fire. So this is how we make it. Slowly we rotate slowly and make a cable. This is preparation of cable using hot air and cable shelling. Let's rotate. Now you can see this. Now this cable, the shelling is not coming out. Shelling is not coming out, fixed now. Now if you cut this and this area, it look like a cable only. How it look like? It's cable only. Cable must have minimum 2 wires or more. So it is having 2 wires. Now like this is the printer cable. How many wires inside you will have? We have 5 wires inside. 1, 2, 3, 4 on the top. 5 wires will have. This is also a cable, printer cable. Now this is a power cable. Power cable will have 3 wires. See, earth, phase and neutral. So this is named as power cable. So it is also a cable. So practical session is over. Now we will come to that remaining part. That is what we finished. Wire joints we finished. That is rat tail joint and pigtail joint, which is the simplest, but now it's the strongest. And we studied about the married joint and Western Union splice joint. These are 2 are same procedure, but if we have single strand of conductor, then we name it as Western Union splice joint. If we have multi-strand connector, we will name it as married joint. Now coming after these joints, what we made? We made the soldering. For the soldering we need 2 items. One is soldering paste and soldering material. Generally we call soldering flux, that is lead. Now coming to this is a brief theory, it's already in the manual, we can go through it. Now procedure also I explained step by step about the joints, about the soldering and cable preparation. For cable preparation, what we need? We need a cable shelling and minimum 2 number of wires or more, so that we have to prepare a cable. Cable definition is nothing but 2 or more strands of wires joined together with a new insulation on it. It is called a cable. So for that, what I explained in the lab session is we are having 2 different wires. On that, a cable shelling is placed and a hot air is blown on that cable shelling after fixing, keeping the wires inside the cable shelling, so that the cable shelling will melt slightly and fix on the wires. So it becomes a complete cable. So what are the observations? So coming to the observations, mainly for naming, how we call it as a cable. So if it is a single strand wire, the cable design is nothing but it's a wire only, and that wire can be used as a phase wire or hot wiring. Now if we have 2 strands of wire, then it is called as a cable. So one of the wire we can use, generally red wire, you can use as a hot wire or phase wire, and blue wire if we are using, then we can use it as a neutral wire. Either or we can use, but general in electrical wiring, to avoid the errors in wiring, we use color codes. That is, colors means red wire generally phase, blue wire neutral, and black wire for earth. Green are there, green also we can use neutral or earth, but red generally we will use for the phase wire for AC supply, and DC supply plus wire we will use as a red wire. Now for 3 strands, if we have 3 strands of wires, then that cable it is, but that cable is named as power cable, that I already shown you, which is used for the computer, iron box, any big devices which having the outer cover iron, because if any leakage is there, that iron cover of that device will get affected with that leakage current. If whenever we touch that box, we will get a shock. So to avoid or to bypass that leakage current through somehow, that is called earthing. So that is called earthing. So that earthing is done through the earth wire. So yellow wire generally we use, or green wire we can use, ground or earth wire. So whatever the leakage current is there, if somehow if any leakage current is there, that is bypassed through the low resistance path, that is earth wire or ground wire, to the ground, and it is connected centrally for a house. 1 or 2 earth pits will be there where the leakage current will go to the earth. For big industry, big processes are there, separate earth pits for different stages we will have, that will take care of it. Now that's why the 3 strand wire is called power cable. First red wire we will use for hot or phase wire, blue wire we will use for neutral, yellow wire ground or earth wire. Now if we have 5 strands of wire, then that is called printer R and data cable. Printer cable, generally olden days we have printer cable, 40 pin cable. So I am not talking about the nowadays what we have, wireless also we have, and a cable is connected to the computer or laptop, and that is USB cable, universal serial bus cable. That USB cable will have 5 strands of wire. Okay, so that is called printer cable. And same thing, that USB can be used as a data cable also, which we are using for the mobiles, where we use for charging and data transfer from files from the mobile to the computer or laptop. So that also have 5 strands of wires. That's why it is called printer or data cable. Now if we have 8 strands of wire, then it is called Ethernet or LAN cable, or internet cable also we can call. Ethernet or LAN. LAN means local area network cable. So this cable used to communicate between server to the client, where internet is connected and files are transferred. So this is called Ethernet or LAN cable. Okay, so this is about the first experiment what we studied. Magnet joint we studied in practical session, and we prepared a cable by using a workstation. That black box is called workstation. Okay, thank you for listening.